साइकिल उधर पार्क 651। हाँ Good evening, everyone. Welcome to the last week of online discussion on wastewater treatment and recycling. Uh, the course instructor for this subject is Professor Manoj Kumar Tiwari, and my name is Manyatnam Prakash, and I am also from IIT Kanpur. As this is last session, there is one extra session that will be on Saturday from 6 p.m. Same link will be used as this one, and you all will get a mail from NPTEL regarding this extra session. So if you have any kind of question or any kind of doubt, you can always join that session. So so uh, mm, and the recording of all the session from starting from week 1 to week 12 and that extra session will be uploaded on this YouTube channel. So do check that if you have any kind of doubt on whatever we have discussed in past sessions, so you can just go and rewatch those video, or we can discuss in this session or in upcoming session, extra session, if you have any kind of question. Okay. So the weeks till now we were seeing discussing about what is wastewater, how those are treated, what are its different component, and what are different practices via which the wastewater are being treated. Okay. So in this hmm. So in this session we will be discussing what happened after wastewater. So we know that there is a concept of reuse of wastewater. So we will be looking into challenges, what are different challenges, and what is the risks of wastewater reuse and recycling. And one more thing is research trend. Like we know that right now new edge with with time there is too much research going on water wastewater treatment and all these things. So we have seen conventional method. So what are the new research that are being done to treat wastewater in a more efficient way, so that will make the wastewater can be treated in such a way that it can be reused or recycled. Okay. Then what is the decision making, like what should be the different decision that should be taken during, we will be looking into these topics. Okay. Then public acceptance for recycled water use. So this is a very challenging thing that now suppose somebody is giving the water and saying that this water is wastewater treatment treated water, and so there is our mindset that this is coming from wastewater and all these things. So this type of things, like this type of thing just cause some kind of hesitation to use that water. So we will be looking into that thing also, what are the different perspective of different people, uh, and how they are reacting towards the wastewater reuse. Okay. And finally, what is the different global practices and case studies that are currently giving us a story that if wastewater treatment can be done in a this reuse and recycle can be done in a innovative way and well planned way, then then what is the benefit of that? There are many stories from India, from outside India, many countries. So we will be looking into those things also. Okay, now. So just before going to the lecture, I just want to go to this thing that is ours big 12. Hmm. Just wanted to go through these the this class notes, that lecture note that was shared with you. So here you can see, like last time we were seeing this thing only on regulation, policies and legislation. Then there is consumer, and then there is a system analysis which analyze our water and all this thing. Okay, now. So challenges and risks. So there is like reclaimed water use is too far complicated than using conventional water. Like this type of complexity is there. Then there is a technical competence, that the high degree of technical competition is needed for fresh water recycling than conventional water use. Then there is this is very costly thing. Okay, then we have seen that new technology required like membrane and all this thing, so it is little bit costly. Then system reliability, like ensuring system is must for wastewater treatment facility targeting. So like we the system should be, the design should be such a way that it can just treat the wastewater in such a way that water can be recycled. Okay, the main challenges which is being generally faced and people are facing is this social acceptability. There is people perception that recycled water can pose a significant human health risk. So this is just a misconception, or like our perception, our mindset work in a such a way that we think that as this water is coming from wastewater, after treatment of wastewater, so this might contain some kind of disease and all these things. So that's not good. We have to change this thing, and there, we'll be talking about a strategy also, like how this can be changed. Trade barriers, possibility of trade barriers escape for food products. This is also thing. Political constraint, lack of political motivation is one of the major hurdle in West. So people like see in country like India, we are not focusing on this wastewater treatment. Just we are just here just, so there is some degree of treatment and we are discharging into river, and we are fully reliable on our groundwater and all this thing, because there is no, like, how to explain this thing, better not explain. Hmm. Then research trend, there are many trend, ongoing trend is going on. We will be looking into details. Okay, now first is like first the the research is going on water reclamation and reuse. Intensive research focus on reusing of treated wastewater for both drinking. So this is like some, like we are just what we are calling, we are investing too much on this wastewater treatment, so that we should not be reliable on our groundwater that is really fresh. We don't want to disturb our nature, because we have seen people many parts of the world. You can see the story in India also, that during summer there is this condition of drought and all these things people are facing. People are not getting water. So one way is to just reuse the wastewater after treatment. So for that there are many ongoing research is going on. Okay, na? Fit for purpose water reuse, identifying the cost effective treatment extends the need for fit for purpose water reuse. This is self explanatory. Integrating wastewater into urban water cycle to use this alternative source along with storm water and all these things. Okay, so this all are like ongoing research trend. Energy production and conservation, wastewater treatment and recycling requires energy, and then energy itself requires a sufficient amount of water to operate. Researchers are exploring water energy nexus to develop establish more energy efficient technology for wastewater treatment and alternatively energy production method from wastewater. And you can see this is a cycle thing. Like we want to treat water, then for treatment we need some equipment, and that equipment requires some kind of water. So that equipment requires some kind of energy, and somehow in production of energy we are again consuming some water. So they are just trying to do something so that they don't have to dependent upon, they don't have to invest too much on energy. So see here you can see that they are see what they are, there is this wastewater treatment energy associated with use of water and water for energy. So what they are using, that they are just using hydropower or thermoelectrical cooling and all these things. extraction and all these things. So just they just somehow ongoing, there is this ongoing research just to maximize the energy production and consumption, so that wastewater can be treated in a efficient way. And there is no such like investment of fresh water, and energy production is optimum and all these things. Nutrient management, changing regulation and increasing stringent effluent limits brought. So again, this is like we just want to again this is like how we are what do I say, what do I say so what is the purpose of our treated water? So again we are again like this thing all depend upon those things only. Oh, sorry. Hmm. So those who have joined now, so just I'm going through the some of the some of the challenges, some of the ongoing research that is going on in world regarding the treatment, wastewater treatment. Okay, na. So if you have any kind of doubt, you can ask. So I will be going one by one. So another is residual and biosolid management. So we know that when this wastewater is treated, a huge amount of sludge is treated, because our wastewater is mostly organic in nature. Okay, so ongoing research is, there are a lot of researchers. You will find a lot of researchers. So I can name also in IIT Kanpur, in IIT Kharagpur. There are many professors who are working on this thing, this biosolids and all these things. Okay, so they are just trying to like they are just the sludge which is getting which is being produced from wastewater treatment, are being utilized in some useful. So we know the in conventional method, we know that they are treating it in anaerobically and they are producing methane. But we have also looked at that they have some limitation and all these things. So more advanced research, just you can just on Google Scholar you can search. Okay, industrial wastewater treatment modeling, design, operation of industrial wastewater treatment. So see, this industrial treatment of industrial wastewater is little bit challenging, because suppose if I'm talking about Kanpur, so we know that in Kanpur there is this chromium industry, not chromium industry, leather industry is there which utilizes chromium. So see here in for treatment of chromium, there is one separate thing, like they utilize they just go through some process, but still that is not fulfilling. The water, the treated water which is being discharged through canal are still contain some kind of chromium, because their method or their treatment method is not so good. So so it's like really challenging and all this thing. Research is going on that also, like how to treat those chromium and all this thing. Innovative technology idea, again same thing. Water, wastewater utility management, instrumentation control. So cost reduction, like for we know that a huge, in conventional method a huge cost is required for building any equipment and all these things. Okay now. And these are things. Complexity of wastewater management, wastewater treatment and are complex and dynamic in nature. So uh, So I think you have already. I will be just going through some of the popular treatment system of wastewater treatment: biological low rate system, natural system constructed. We have seen these things: constructed wetland, vertical soil filters. So these are some of the popular treatment method. Then membrane, but we know that these are also costly and not so not economical for people in economical society. So I think I will request to this slide, this the PDF of this has been already been shared with you. Okay, na. So I was just giving a small idea what's in this. What kind of generally like research is going on, and there is the then there is this question: is wastewater is a technical challenge and all these things. So it depends upon many things. Okay, na. So so instead of going through these notes, I have tried to make some small what do I call uh, summary of all these things. Okay, now so I will be going through one by one, and then there will be some question related to this that you can expect in your exam and all this thing. Okay, so this is just simple conventional method. Okay, so coming to the this challenges, risk and research trends. Okay, now the challenges in wastewater is complexity. Recycling water is more complex than using recycling. What see when we are talking about recycling, we are just saying that we want to use for particular purpose. In conventional method, what we are just mostly dealing with discharge and all these things. We are not treating at that level that it can be reused. Now we are talking about that we want to recycle or reuse. Then we know that for drinking water there is specific limit. For irrigational purpose there is a specific limit. So now the process is has become complex. So we have to we have to develop such technology that can treat the wastewater in a such level. So this method somehow become complex than conventional method. In conventional method, what happened? That simply water will come to this um, different unit first. Say first this. A screening chamber, then grid chamber, then PST, then SST, and all this thing. Okay, but for a particular purpose, we have to like we have to like develop particular. We have to remove all the unwanted things in wastewater and all this thing. Somehow process. Obviously, when we are developing technology and all this thing and for advanced treatment there is some cost investment, so that's how this system become costly. The whole system become costly. Technical competence, recycling process require higher level of technical expertise. Like simply we cannot rely on like anyone can operate the wastewater. Once the system become like we know that suppose there is one treatment plant which is using membrane and all these things, so we know that there should be regular cleaning. So there should be some expertise who can just guide how the system works. So technical means like there should be some person who should be like well educated to handle those things. So somehow this is one challenge. System reliability, ensuring system performs in critical and successful water recycling. System should be like we have to make system such a way that it can treat our wastewater to a such extent that that can be recycled, that can be reused at some point. Now this is the most challenging part. The like initially I was saying that if someone gives you water you will and you will be say that this water contains some kind of wastewater, it was from wastewater, then there are high chances that you might feel that as this is from wastewater, so it might contain some kind of pathogens and all these things. So this is like our perception. So this perception has to be changed because we are relying on the see when someone will be giving you treated wastewater, so a huge amount of investment has been done, a huge amount of research has been done. So so you should somehow like see it depend upon region to region also. For example here in like so this is very interesting topic like where people should accept things and people are not expecting expect, accepting the this reuse and all these things. So with upcoming slide I will discuss about this more about this thing, but it's not it's not completely people fault that they are not accepting this wastewater for their use. There are some examples where people are blindly using it and they are getting benefits, and there are some examples like where people were asked to use treated wastewater and somehow when they started to use treated wastewater then they were getting negative results. So this was like a trust. there was no such like trust breaking things. So that's why sometimes people, and we know that negative things spread fast. So people started to believe that we won't be using treated wastewater for our irrigation purpose or for any purpose. Okay. Risks in wastewater recycling, public opposition, misconception about safety of recycled water after resulting social resistance, especially for potable water, political trade barriers, and over treatment. So this means like see, somehow political connection also play a role in use of food. And now suppose there is no one is talking about that we should be using treated wastewater. So common people won't be getting any idea until or unless there is an advertisement. Yes, this is treated wastewater, and someone is certifying that yes, you can use this water for your drinking purpose and all these things. Then you can trust him and you can just use it. But I think in India this is a big problem that nobody like so first like see I just don't want to discuss it. But in India there is much bigger problem. Okay, now, but I think you should be getting what I am saying. Overtreatment, producing butter of higher quality than needed for a specific use application can lead to unnecessary cost. Now, this is another challenge. Like suppose, um, mm, like we want to suppose butter is being demanded for educational purpose. So we should not invest such a that we should be investing in such a amount in such a way that it fulfills our requirement and there is no extra thing going on. So because that will be just taking some extra money and extra investment and all those thing. So this thing I was saying that then decision making. So again I mean it's like this thing this thing we have talked that what is the technical challenges that its advanced treatment are expensive and complex to implement. We have seen that nowadays the concept of this reverse osmosis, membrane filtration, UV, but these are very complex. And if you now at a rate at which we are producing wastewater, and if we want to treat those wastewater by this advanced process, then there should be some money. Okay, now without any cost, without this thing, the whole thing system will fail. Okay, because there is regular maintenance, there is expertise. Now suppose if you are hiring some well educated person to run, so there should be some kind of salary and all this thing, because they won't be working on lower salary and all this thing. So somehow it's become complex. Okay, high energy demand in education infrastructure where wastewater treatment and distribution is quite costly affiliates. We have already. Mm, there then there is this yuck factor. Okay, na yuck factor. Like we have also used this term yuck. We don't want to accept those things. Suppose something where some food or some water which is are being given to us, and that you somehow you have perception that this was not prepared in a well way, then there will be some this yuck factor that I don't want to use that. Okay, created resistance to use of recycled water for drinking despite proven safety. So this is a big challenge. Inspired. So this is seen that in spite of saying this that this wastewater which is being given to you is free from any contaminant and it is safe. It is just passing all the drinking water limit. Still, people somehow just tends not to use that wastewater, treated wastewater. Okay, lack of this thing I have already said. Then question is what is the those risks that what we are talking about the risks now. What is those risks? Then the first is health risk. Okay, now so people may pathogens may persist in treated water, posing risks if reused for potable water without proper safeguard. Okay, now so this is another like challenge, not challenge, but kind of risk, health risk. Chemical contaminants. Suppose we have seen that if those, if like, so it's like it's giving you idea that this you if you are treating a wastewater, you should keep this thing that it should be free from any pathogen, it should be free from any heavy metals, because somehow if those are in water, and if you are saying that it is safe and people start to consume, then it will just harm you, it will just harm both, like it will harm, obviously if people are consuming, then it will harm people, and it will be like not like it won't be good environmental risks. Now suppose so this is, I have seen this example, okay na, so this is in Kanpur only. So this, then there is this Jajamao plant, they are discharging wastewater. So so they are discharging treated wastewater, saying that it's good for your irrigation, but it has been observed that the productivity of the villagers who were using this canal water has reduced significantly, okay na. So you can just I don't know, remember any, in my lab also this work is going on. So in deep this work is going on. So this how treated water is being carried from a starting, means how the whole geochemistry and how this conversion and all these things, how they are affecting soil. So a complete detailed work is being done in my lab. So I think in few and upcoming days we will be looking into a detailed report. Hmm. But this is the live example which we have seen, that if you now imagine that you are giving something to soil which is not required, so obviously the soil will respond in some way. So it will be contagion. It will be not good for soil, and your productivity will be. Continuous use of wastewater can lead to soil degradation, especially with high salinity or nutrient content. Poorly treated wastewater in water bodies, and again, suppose if you are suppose it's not that much treated, and you are just throwing in wastewater, you are just throwing it in a river, then obviously it will cause eutrophication because it contains nitrogen and phosphorus, and that will eventually kill your aquatic life. And then there is this operational risks. Again, this is related to advanced technology, and you should make sure that system is working fine, because any failure at any point will lead to some kind of health risk or environmental risk. Okay, so all these are related to each other. Then again, we have talking about this thing we have already talked. Okay, now this thing we have already talked, and if you want to look into more detail, I will just suggest you to go to the PDF which has been shared to you. Here you will see many things. Okay, now we were discussing what are the different research, and if you don't want to go into this slide, you can just go and search on internet on Google Scholar, like what you can search, you can just search wastewater, advanced wastewater treatment, then you will be getting many ideas. Okay. Hmm. Then second topic we were about this decision making in wastewater reuse. Okay, now so see, effective decision making in wastewater reuse and recycling involve balancing technical, environmental, and socio and economical factor to ensure a sustainable and safe implementation. So this is most important. Like if you are see if you are there should be some decision, um, um like obviously if we talk in a normal sense, it's like what is the final aim of our treated wastewater, based on that we'll be taking some decision. Okay, now suppose if we are treating wastewater to discharge in river, so there should be some treatment requirement, and we will be taking decision based on those things. Okay, now so now suppose then if we are recycling wastewater for drinking purpose, again in that case we have to look into this water some treatment method and all these things. Okay, now so there are several decision making in wastewater, so I will be going one by one. Okay, now water quality requirements fit to. So this is the most, like, if you are use water quality, lack of level of treatment required depend upon the intended use. Remember, always intended use, whether you are going for drinking water or irrigational purpose or discharge in river, all depends, degree of treatment depends. So you have to take decision based on what is your final aim. The level of treatment required depend upon the intended use of the recycled water. For agriculture irrigation, lower quality water may suffice, while potable use require advanced treatment. Okay, for irrigational, we don't require that much treatment, but for potable water, advanced treatment should be there. Regulatory compliance. Obviously, we have seen that for India there is IS code, then CPCB. So if you are treating wastewater for drinking water, then all the criteria that is mentioned in IS 10500 2022 should meet. Then only that water is will be called for drinking purpose. And on another hand, if you are going for irrigational purpose, then there is some limits by CPCB, pollution control board, ZLD, and all these things. ZLD, I don't recall. Only CPCB, pollution control board. Okay, na. Then there is yes. So all the it should meet the criteria given by those companies. Okay, those policy maker. Okay. Then there is the treatment technology. So again, just I will read out technology selection. Decision maker needs to choose appropriate treatment technology based on a specific contaminant present in wastewater. Again, I have said you. So if high pathogens is there, so such technology should be there that it can kill all the pathogens. Suppose say some heavy metals is there, say chromium is there, arsenic is there, or fluoride is there, then some decision should be technology which has to be implemented should be taken in a based on this aim that after treatment those contaminants are being removed. Okay, na. Energy efficient should be there. So, again, I have already talked that if something is there for advanced treatment is there, then there will be requirement of external energy, and for external energy again we have to spend and all this thing. Then there is cost consideration, capital and operational cost is there. Initial capital investment in return plan, ongoing maintenance and must be evaluated. Cost recovery method setting. See, generally cost recovery again there should be like see, one of the main challenging main thing about this thing in cost, like we know that there is advance there will be there will be some initial cost investment, and there will be regular maintenance cost. So things should be done in a such a way that all this like see, now suppose in an area, uh, suppose this is our wastewater and there is a canal and water is going, and there is a field here and then there is a field here. So obviously for laying out this canal and wastewater there is some investment. Okay, na. So generally it is suggested that so it's like I don't know. I should like what I should say. Hmm. Now, what should happen that obviously the main challenging is that with time there is a regular maintenance. So sometime it in India or at some place it has been seen that as they are like whatever they are spending, they are not getting back. Like I'm not just remember what is this cost recovery. Like there should be some method to recover the cost investment or all these things. So in short I can say that if they are using this treated wastewater, then they should pay something. But the question is that are they whatever they are discharging it, or is it suitable for my river and all for my soil and all these things. So a lot of question and lot of discussion can go on, But I'm just saying that this kind of decision should be taken. Okay, now environmental impact, again we have seen that uh, in treatment of that wastewater, are we like are we are we degrading our environment and all these things. So this should be also checked. Decision making should factor in potential for recovering valuable source from wastewater and all these things. Protection should be there. Then social acceptance and engagement, public perception, public engaging the local community is crucial, especially when it comes to potable reuse, where the public might register ideal drinking recycled water. This thing already, these yuck factors coming into the mind. Okay, now education and awareness, and the most it has been seen that the main cause for this kind of perception is only due to education, only due to basic education. Like if some like generally it's trend that generally, like you can understand, like it should be, people should be made aware or made somehow. If they are aware that this is safe to drink, then they will drink without any hesitation. Okay, na? Then there should be risk management, health risk, ensuring the safe reuse of treated wastewater. It is free from any pathogens and all these things. Then there is environmental risk and all these things. Okay, so all these things should be considered. Policy regulatory framework, we have seen that it should meet some criteria. Okay, now so the regulatory alignment, decision maker must align with the national all the, suppose if your intended purpose is for drinking water, then it should meet the IS code. And then another program is incentive program is government can offer incentive to encourage the adoption of. So this can be another thing, suppose if you suppose, similar to solar power plant, people say that government of India is saying that if you are applying solar panel at your home, then we will be giving some kind of incentive subsidy and all these things. Similar things should be said to wastewater, that if you are using if you are using wastewater treated wastewater, then we will be providing some kind of incentive and all these things. So in this way, what will happen that um, we will if people start to follow this, then we will somehow will be controlling our dependency on fresh groundwater. Okay, na? Then economical and institutional factors, collaboration with multiple stakeholders, government agency, and is a vital for successful planning, funding and investment. Obviously, there should be some funding. Long-term sustainability. Obviously, long-term it should be working for very long time. It's not like that. The system is working for only one year and all this thing. No, it's not good. Continuous monitoring of wastewater sustainability performance combined with a adoptive strategy ensure the long-term sustainability of wastewater. Scalability, decision maker must consider scalability of the reuse system, ensuring that they can expand to meet the future demand and all these things. Innovative research, we all seeing that we have already discussed. And whatever the new technology or whatever the new advancement is coming, we should just follow up on those. It's not like that someone has done it then done it. It's not like that. If some new treatment of wastewater has come into the existent with some new technology, then people should start like the person should start looking into those new technology. It's not like that they should be reliable on the conventional method. That's not good. Okay, now by carefully considering these factors, decision maker can promote the sustainable wastewater reuse and recycling practice that benefit both society. Okay, so this was all about decision making. So I have uh, uh, told about around 10 factors which should be considered for decision making. So now I will be talking about public acceptance for recycled wastewater. So before going into that, please take your time. If you have any question, you can unmute yourself and ask, or you can write in chat box also. Please ask. This is last session, and there will be one more session. Those who have joined little late on 19th, you will get notification. Okay, now. So remember my Google link end with TPK. You will be getting. I don't know about other TA, but I am taking one extra session on 19th on this Saturday from 6 p.m. to 8 p.m. It will be I won't be taking any kind of class and all this thing. It will be just what do I call a summary type of thing. Okay, na. So where if you have any kind of question, you can just ask. So I will request everyone to do join that session. So actually those who have joined my session previously, there was one time that I was discussing about my lab. So I wanted to, so there was someone who was asking that please show your lab, but due to some time constraint I was not able to show my lab. So on 19th we will have some time, and I think I can give you a brief tour of my lab, how we are working and all this thing. Okay, na. What are the different equipment we are using to analyze. So I am also working on, I'm not working on wastewater, I am working on groundwater treatment. So you can have an idea. Okay, now. So I will, it will be good for you. If you are curious, just join that session. uh, Anyone have any kind of question? I'm not. No, no question. Hmm. So public acceptance is one of the most significant challenge in promoting the use of wastewater. We have already seen. Understanding and addressing public concern is the crucial for success wastewater recycling projects. The key factor is influencing public acceptance and strategy to enhance its include. Okay, the first is psychological and cultural perception. Perception. Yuck factor. We have already discussed about yuck factor. Yuck. A major barrier in inherent discomfort of many people feels. Uh, hmm. So the concept of water being previously dirty creates emotional resistance, even if water is scientifically proven to safe. So this is just a perception. We cannot change it. Perception. Sorry, perception. Perception. Hmm. Then cultural benefits in some culture, wastewater use may conflict with. Then this is another problem. Health and safety concern. Safety of treated water. People often worry about the presence of pathogens, chemicals. We have already touched in technology. There can be aspect about the effectiveness and reliability of treated technology used, especially when there is a limited public understanding of the process. Okay, now. So this is another challenge. Like, and one should follow it. Like suppose I have developed some technology, and I have seen examples also. So I suppose if I have seen I have developed some technology and I want to implement it. So, and and it involves direct involvement of local people. So we should be giving them a just 1 minute. Huh. So we should be given a we should give them a complete details what they are what what kind of water they will be getting, how they are getting that water. That will make ensure that they are sure that whatever the pathogens and everything that is present in the water are being killed. If that is not being done, then it's like it's like keeping them in a dark and asking them to use something which they don't know. Obviously they won't be using those things. Okay na. So we should be giving all the details and all these things. Lack of awareness, again I have talked about this lack of awareness and knowledge. Okay now, so this is another challenge. Like people they don't have knowledge and all these things. So once they start to like once they started to show them, like there should be some kind of community meeting or group meeting where like we will call all the locals and we will start saying that, see the what is the new technology, what is the use of and all this thing. So we should start explaining what is the problem first. As we are using fresh water, we are just then this kind of sort we have to make them somehow understand. Okay now, once they are aware that yes, something is wrong, then I think in history it has been seen that if people are made understand that yes, there is some problem ongoing and we are providing some kind of solution, then people will accept your solution. And uh, once only problem that we have to make them aware about that new technology. Misinformation and media influence. Negative media coverage. Media reports that sensational risks or incident involving water contamination can amplify public fears. And so we have seen that some like see now 100 good things are going on, and one suppose they, out of 100 one things is not going good. So it's like a tendency that people will start focusing on what's going wrong. Okay now, so this kind of trend should be stopped, because people will start like seeing more, will be start more focusing on those negative things, and somehow it will like it's not related to wastewater, it's related to our normal life also. We started to see on negative things and all. Then the government interest and institute, public influence institute responsible for treating. Then there should be like those who are treating those wastewater. We should trust them. There are some cases where there are high chances that those the person the party which is treating wastewater is not doing their work. Then we should just file a complaint and all these things. But at some places it has been said that people are getting good result. Then I was saying that now we were saying that what are those problems, and now how to enhance public acceptance, like what should we do. Then first we have already seen public education and awareness campaign. Educational program in a school, workshop and media campaign can emphasize that environment and wastewater security advantage of recycling water. Okay. Then community engagement and we should be involving locals in treatment and all these things, so that they are aware and they can use it. Okay now, so like for treatment purpose we are using the person who will be using that water. So it will be like so now like it will be more efficient and all these things, so people will start accepting. Transparency in communication, consistently providing clear and science-based information about the quality and safety of the recycled water. Public agencies should be open about the potential risks and all these things. Pilot project and successful stories. We should start saying some stories and all these things. Some stories such as Singapore, New Water, Orange County in California, and we have there is something in Bangalore also. I don't recall. Then there is this Israel water scarcity and its revolution and all these things. So that is the best example till now, how they have like once they were scarred, there was water scarcity in that area. Now they have managed their water in a such a way that they are using water in a very efficient way and all these things. Use of celebrity endorsement and opinions leader we have already seen. Clear label and marketing, there should be some. marketing and all these things, then demonstrating regional standard and all these things. So these are different way by which we can aware the people. Okay. So global practices, what is the what people are using with gold, with this wastewater. First is irrigational agricultural irrigation. Irrigation, agriculture irrigation. Okay. We have already seen this, that recycled water is frequently used for agriculture irrigation in water scarred region, as it is provides a reliable and drought resistant water source. Okay. Any doubt?
Hello. Whether agriculture water is free from pathogens?
Water should be, you were not audible, please say again.
Free from pathogens? Agriculture.
Agricultural water, yes, it should be free from pathogens. It should be free from pathogens. Yes. Treated, if you are talking about this, see, I have see, you can write in chat box also. You are not audible. Treated what, so see, obviously it should be free from pathogens. See, pathogens, treat, yes, it should be free from pathogens. For agricultural use, it should be free from pathogens, because somehow it will just, if pathogens are very they have tendency of this bioaccumulation. So once it is in water, it will start accumulating in, or suppose some it will start like yes, if pathogens are there, somehow it will affect your soil. If it will affect it will affect our crops and all these things. In presence of pathogens, it has been seen there are many papers means research papers which is suggesting that in presence of pathogens, I won't be getting a good productivity. And in presence of pathogens, there will be unwanted things and all these things that will somehow degrade your crop and all these things. I hope I am clear to you. Hmm. Recycled water is frequently used for and it should, it can supply essential. So see, we know that see now it doesn't mean that you should allow all the nutrient nitrogen and phosphorus to pass in the agriculture's limit. So there is some a standard set by pollution control board or some board, that if you are discharging your wastewater for irrigational purpose, then this much of nitrogen and this much of phosphorus should be there, not more than that. Okay. So in that way, what will happen, that not high amount of nitrogen and phosphorus is going in the land, in the in our soil. Whatever the required amount of nitrogen and phosphorus is there for our crop is being provided, because excess amount of nitrogen and phosphorus can also lead to some kind of damage. Okay now, so the amount of nitrogen and phosphorus required for nutrients are, like, there is some limit. Okay. Then we have industrial use. Many industry use treated wastewater for cooling, processing, and cleaning. This reduces the demand for fresh water in industrial activity, conserving resources. The practice is common in sectors such as water generation, power generation, petrochemical, and textile. Then urban and non-potable application. We have seen this gardening and all this thing. Okay, in urban area, recycle grey water is usually used for non-domestic uses. Gray water. Yes, huh? Yes, like for yes, we have discussed this thing in last class. You gray water recycling, because this is most generally it is like detergent, like kitchen, not kitchen, like it contains less amount of organic matter. It's the amount of inorganic matter is very high, so treatment is very easy. So what is happening that it is it's what is used for one use, is used for one, for non-domestic. Non-domestic, like you have to define non-domestic. Like see, there is one in our home also we are using for, if they are we have seen that 4 5 application. First is gardening, then car washing, then toilet flushing, and all these things we can use that, this water. So I won't be saying one only for non-domestic purpose. For domestic purpose, for domestic purpose, non-domestic. Yeah, it is only for non-domestic. We are not like, we are not drinking and all these things. So gray water is like, yes. So whatever you are saying is correct. Okay, then particular direct and indirect reuse involve treating wastewater to meet drinking water standard. Indirect reuse. So this thing we have seen, direct and indirect non-potable reuse system are commonly implemented in residential and commercial building, helping to reduce wastewater consumption. Though the less common potable reuse in growing cereal. So like there are some hmm, there are some cases where we can like after some level of degree of treatment, um, we can be like mm, we can drink that water and all this thing. Okay, then I was discussing about some of the case study. The one most famous successful case study of reuse is Singapore new water. So Singapore is renowned for its innovative water management practices. In its new water initiative is one of the world's most successful potable reuse projects. Singapore uses reuse treated wastewater using combination. Singapore water reuse system treat wastewater using combination of microfiltration, reverse osmosis, and ultraviolet disinfection. This produce high quality of ultra pure water that meets the drinking water standard. So they are using some kind of this kind of advanced technology such as filtration, reverse osmosis, and they are taking drinking water that people are using in Singapore. Okay, usage new water supply approximately 40% of the Singapore water demand, with the majority of used for industrial purpose, and a small portion is directly for human consumption during dry periods. Remember, see, so during dry periods, they are like they are treating their wastewater in such a way that 40% of their demand is being just fulfilled by the treatment of wastewater. Okay, public acceptance. Singapore has successfully managed to overcome the public resistance by rebranding recycled water and running extensive public education campaign to promote new water safety. So, see, this is the most important. Public should accept it. So for that, they have invested too much. Government were educating the people. They were advertising and all this thing. Okay, now. Hmm. Then we have another case of California, Orange County, California. So there was groundwater replenishment system (GWRS). So the groundwater in Orange County is one of the world's most largest and most advanced indirect potable reuse projects. The system treats wastewater through microfiltration, reverse osmosis, and UV disinfection. The treated water is then injected into groundwater aquifers to replenish natural water supply. So again they are investing in advanced technology. Water supply, the water provided enough water for nearly this much people annually and has become crucial part of Orange County water strategy, helping the region cope up with the drought. So they are just with the help of this wastewater treatment, they are just coping with the coping during drought season. Environmental benefits, the again same thing. Then we have this thing. See, read this thing. Israel has one of the most advanced wastewater treatment recycling system in the world, recycling about 90% of its wastewater, primarily for agriculture educational. Can you imagine 90% of the agriculture demand is being, like, this is huge. And we know that in agriculture we are in India, we are dependent on our groundwater. If you visit any village and you will see they have built this borewell, there is one pump, and during their this season, watering season, I don't know a specific name, they will be pumping water from for hours to supply in the field. So that is not good. We are just destroying our storage. Okay. Located, so this wastewater treatment is located near this plant, and treat recharge treated wastewater into aquifer, which is later extracted for irrigational purpose. Okay, now tell. So see, the most important role there is University of Technion University. Technion University is there in this area. So means they are just whatever, means they are just helping, and they are awaiting the people and all these things. So that's why, like, people are also, you can understand. Agriculture impact, recycle wastewater supply 50% of the agriculture water needs in every country to maintain agriculture productivity in desert climate. The success of wastewater is supported by strong government and clear regulation and irrigation of wastewater recycling. So we can, again there is some case of Namibia, then Spain, same thing. They are just using some kind of advanced treatment. What is the benefit of groundwater recharging? What is the benefit of groundwater recharge in borewell pumps? Recharge, when we are recharging our groundwater, then see, recharge can happen in two way. One is natural recharge, that what happened that what happened that water will percolate from surface to the this aquifers, and what will happen that water will percolate in the ground, through the ground, and it will meet the aquifer. So once the aquifer are filled, we can just take out the water. And there is another process of saying, you are saying that we are recharging through bore wells. So uh, generally this is artificial method of, you might be seeing, if you see, like, there are many places that what happened that if natural recharge is not happening, and like natural recharge is not happening, so people tends to build artificial recharge system through bore wells. So what will happen that there will be some kind of arrangement. So here there will be a borewell, here there will be borewell. Suppose this is large area, okay now, and suppose this is large area, this is very large area, consider the very large area. So a special kind of arrangement will be made. It's not like that water will be passed through directly through this borewell to the our aquifer. So what will happen, there will be some kind of catchment area. First a catchment area will be there. What will happen, suppose in that area, whatever water is there, it will go to the catchment area, and there will be a pipe con- there will be a pipe connecting this catchment area. It will goes through some kind of tank, then through some filtration unit, and finally it will go to this bore well. Okay now, so in this way what we are doing that, uh, if water is passing through this filtration system, so whatever any kind of sediment is there, and any kind of sediment is there, or it will be removed, and water we will be getting our aquifer recharge. So what is the benefits that the water which was laying around on the surface that might have evaporated with time is now being used to recharge our wastewater, recharge our water with the help of some kind of artificial things, that is borewell. So we are just saving rainwater. If you have to answer it in simple water, you can just say that the water which was relying on our surface, that might have evaporated, so we are passing through the borewell and we are recharging our aquifer. Rainwater or treated wastewater also, if you keep the treated wastewater and if you are not supplying it, it's better to somehow make a mechanism that it will pass in the, it will go through the borewell and it will recharge our aquifer. Did you get it what I was saying? Subhas, whether surrounding area make porous, whether surrounding area make porous, whether surrounding area make porous, which I'm not getting, whether surrounding area make porous. Way, yeah. If see, if your ground is already porous, then it will pass eventually. If it is not porous, then we have to make some kind of arrangement, like this kind of borewell, so that water can percolate. For example, in Kanpur, what is my campus, I have seen, like, I don't know whether I can. I will just search now. But in Kanpur, what is happening? The land is not so much um, porous. So once there is a rain, what happened that it it is not that there is, I don't know, I might be wrong also, but what it is seen that once there is a rain, there is accumulation of rain on the top of, on the our field and all this thing. To cope up with that, they have built a recharge well. What will happen that there is a catchment area, water will pass through that catchment area and then through this borewell, because our system, our land, our soil was not that much porous, so they have built one recharge. Let me show you. IITK recharge. So right now I am not getting that. I'm not getting that structure where there is this complete structure how the water is getting collected, and how water is being collected, and how they are recharging and all this thing. Okay, now so sorry, just I will I take on recharge. I don't know why I'm getting this. Okay, right now I don't have those. So right, sorry, I am not getting it, but this is the main concept that once it is not porous, then we can somehow we have to make another arrangement for recharge and all these things. I will try to draw a rough diagram how that thing works. So there is one football ground here in IIT Kanpur. So once there is a rain, all the water will be accumulating. So beside that football ground, there is this kind of a bale. So what will happen that it will first fill the well, and in that way, and at the top of there is one pipe system, at the bottom at top, then pipe system, then it will pass through one filter unit that contains some kind of gravels and all these things. So what will happen that once water is getting passed, so if there is sediment, all the sediment will be getting collected in this filter unit, and after from filter unit it will just go to this deep well. Okay, now it will go to deep well, and finally it will recharge our aquifer. So this I think it's this is overall, I think you will be getting idea how this thing works, but this is how recharge will look like. So another story of from Australia, Western Corridor Recycle Water Scheme overview. In Queensland was built to add severe drought that affect the region in early. The scheme all use advanced treatment method, including microfiltration, reverse osmosis, and advanced oxidation to produce high quality and recycled water. Originally designed to provide potable water through indirect, again everywhere they have invested. Okay, somehow they have just invested in via money, so that they can work on advanced treatment, and they are not reliable on fresh water and all these things. Okay. See, so one thing is that what should we learn if we are, see, India is still struggling with the groundwater. We know that, and we are not also working on wastewater treatment. So we should learn from them, those who are doing good and who has done good. So first important thing, they have seen that public education is key. Public acceptance is crucial for successful. What's even though if we start treating wastewater, and if public is not educated, public is not willing to accept that treatment, then it's no point of treating those wastewater. Regulatory framework, a clear and robust regulatory framework ensure the safety of treated wastewater and promote public confidence in its reuse. Then innovation in technology, advances in treatment technology such as reverse osmosis, and people should start in government should start investing in technology. Government, and there should be support from government. It's not like that just by thinking, because there will be huge, if we are thinking of advanced treatment, then there should be support from government. Tailored solution for location context, the specific needs, resource, and cultural attitude of different region require tailored solution for wastewater recycling. What works in one area may adjustment to succeed in another. So there should be like it shouldn't be generalized solution. It should be like location varied solution. If some location is have problem with a specific contaminant, then treatment should treat that specific contaminant. And it should not be like that if there is area that it's like, suppose if you are applying advanced technology in an area where there is no such requirement of advanced technology, then it's just a cost. You are just investing in a manner that is not required, so that will be not a cost efficient area. Okay, so this all were about today's session, not today's session, about some of the topics one should be aware. Okay, now one I was saying this thing, for India, I think there is one story from India also which I have not seen discussed. See, this is a story of Singapore. This is a story of that is Orange County. Then we have Florida story also. Israel also. See, Israel, Japan, Japan, Australia, UK, Europe. In India, see, wastewater recycling, many smaller scale are being made and has shown promising results. Chandigarh is the using treated sewage water for horticulture needs for green area. Indian Agriculture Research Institute, Karnal, has recommended an irrigational method for sewage fed tree plantation. Bangalore is Bangalore is the first Indian city is planning to use recycled sewage for augmenting domestic water supply as indirect potable use as a pilot model of Singapore. So Bangalore is trying to copy Singapore. In metropolitan city like Delhi, Mumbai, Bangalore, and Chennai, treated grey water is being used for toilet flushing in some of the major continuous and high-rising complexes on pilot scale. Delhi has put in a place plant to use for treated sewage for Indira Gandhi Airport in Delhi uses different grade of reclaimed water for cooling water, toilet flushing, and horticulture. Then concept of using treated wastewater for industry are also gaining popularity. The purchased secondary treated sewage is being further treated and used in cooling makeup, and so you can see there are many stories from India also. Okay, now the government forcing industry to adopt zero liquid discharge, ensuring complete recycling of industrial. So they are saying that a company should not, a industry should not discharge any wastewater. They can just reuse water after some treatment. Zero ZLD has become mandate for gross polluting industry like thermal power plant, steel manufacturing, petrochemical. Pilot project on groundwater recharge with treated wastewater has also connected. Example Varanasi, Southern. Okay, so in India also there are many storage. Okay, so the course instructor has also given some of the book to read. If you have any kind of more doubt, you can just go through these books to get more idea. Okay, now. Hmm. Coming to the question, so the all this was about. Now we have again same thing. There will be some question and try to answer it. So again, I will request everyone to participate. Identify the incorrect statement regarding the wastewater recycling trends. Incorrect. You have to answer the incorrect statement. Trend of reclaimed water has been increasing worldwide. Yes, that is correct. System for wastewater reclaimation are generic and hence can be easily replicated at other places. No, this is not correct because we have know that some area might contain some kind of contaminant, some area might contain some. So again, agriculture is largest. Yes, this is also correct. Public acceptance usage in progressively growing. Yes, yes. So this is incorrect. So B will be our answer. The correct answer is B. The trend of recognition is correct. We have already seen system of the wastewater reuse generate. So you should be aware of this thing. Okay, now. Incorrect. Wastewater recycling system are highly site-specific and are influenced by local factors such as geography, climate and technology, social acceptance, regulation and economic conditions. The system must be tailored to meet the unique requirement of each location and replication is not always straightforward. Okay. We know that for some area another contaminant might be another contaminant will be what do I call a specific contaminant will be giving problem so it should be such that it's not like that the same process can be applied to another location. Okay. Agriculture, yes, this is correct. Agriculture is indeed largest consumer of reclaimed water globally, especially in water scarce region where we have seen example also in Queensland, in Israel, then in that California, Florida, and all these things. Public acceptance of reclaimed water is yes correct. Public as people are getting more educated, then people are just aware that yes now we should the condition apply that in reality the water is being treated. I have seen one example. I will show you. So here also the government is saying that we are treating water wastewater and what results are really bad. I don't know on what basis they are just saying it, but it's really bad. The challenges in wastewater recycling includes technology and wastewater are prone to frequent failure. There is high risk of health overgrowth by recycled water. High cost is incurred in wastewater recycling, or is it all of above? Hmm. C. Its answer is C. Cost incurred in wastewater recycling. Higher cost incurred in wastewater indeed considered a significant challenge in many countries. Here is a breakdown of why cost setting up wastewater recycling often requires substantial, and so that's why there is a high amount of cost. Okay, na operational cost, ongoing, and long-term viability. Okay, na so to manage all these things, there is huge amount of cost. So, let me see. If you are answering this question, there are high chances that you might be thinking that D is also a correct answer, but D is not correct. That is all of these. Why? A technology are available for wastewater technology are prone to frequency. While this can happen, many modern technology have developed to minimize the failures and error. So see, if we are developing some technology, we are not just developing that it will fail. There will be some failure, but to safeguard those failure, we are also taking some kind of precaution. So if we are reliable on advanced technology, uh, we are making sure that technology does not fail. Okay. So, hmm, uh, technology does not fail. So it is not universal. It may not be universal in universal challenge. It is hard. This is not universally true. With proper many system can usually shape recover this health. This are free dependent can be managed effectively. Okay, now so the see the correct answer. Try to match the class of factor accept aspect affecting the public acceptance of recycled wastewater. Socio-demographic factor, psychological factor, and operational factor. So, see, psychological factor is related to health perception. We have seen this thing, health perception. Operational factor will be related to quality of treated wastewater. One more operational, more treated water. And socio obviously, if the area is developed, then it will be more it will have more money, more education, and all these things. So the answer will be CAB. That is C answer. So this was very quite simple. CAB, huh? The related to characteristics of population such as education and income, which can influence the acceptance of reliable must match C. Okay. Psychological people perception and belief, particularly concerned about health risks associated with recycled water. So health and risk. And operation involves the performance and quality of agents. The correct answer is C. Okay. Then question number 4. Decision making on the selection of an optimum treatment sequence of the wastewater recycling is becoming a challenge for designers due to this thing we have discussed. A steadily growing number of alternative process, inferior performance of wastewater treatment unit, growing level of socially and acceptable to what? Okay. So the increase in availability treatment technology means the designer have to be so its answer is A. Okay, na steady. The increase in available treatment technology means that designer have to be navigate a complex financial problem. Each process may different advances and drawbacks, ecosystem and all this thing we have discussed. Okay, na. So decision making of selection of an optimal treatment method for wastewater is becoming challenge for designer due to obviously uh, many alternative methods are there. So like now they have to decide where they have to rely and all this thing. Okay, now. While the option highlights other option, we also contributed thus the while A is the correct and critical region, the overall multiple region. See here answer can be D can be also answer, but A is the most challenging things. Okay, now. Question number 5. We have discussed this. Fit for purpose wastewater treatment advocates treating wastewater to produce treatment water which is fit for all type of potable and not potable. No, this is incorrect. We have seen that we should not be over treating our water. If we are recycling water for not potable purpose, we cannot use that for potable purpose. We don't want to invest too much. If a water is there for our non-potable purpose, then degree of treatment should be till non-potable only, because we know that there is a separate requirement for potable and there is separate requirement for non-potable. Potable be it should be like there should be some specific minerals and all these things. Non-potable we don't look. There should be high amount of nitrogen and phosphorus for, suppose if it is going for agricultural purpose. So it will be just a not a cost effective method. We are recycling means we have to see that how much we are investing money. So say first statement is incorrect. The fit for purpose treatment may require over treatment in over fit for purpose may require for over treatment in. No, see, if second statement is also incorrect. I think both statements is incorrect. Why? Because see, because we know that if we are knowing our purpose, we are sure that we will be using for potable purpose, be for drinking purpose. Then we will be treating our water for only drinking. The over treatment will be, suppose if we are saying that we will be using for non-drinking purpose and we are treating for potable, then this will be over treatment. Okay, na. So see here, first statement is incorrect. The uh, uh, fit for purpose treatment is specifically focused on treating wastewater to meet the specific quality standards required for its intended use rather than treating it for all possible use. This idea is tailored to the treatment to actual. I hope you are understanding it. Second statement, this concept of fit for does not advocate for over treatment. Rather, it emphasizes treating water to level necessary for. Obviously, we don't want to. That's why it is during decision making we decide, like we should be aware that why we are treating that wastewater. Okay, now if we know that, if we know that, then we won't be over treating and all these things. We won't be doing that. Again, maximum it's wastewater. This is very, we know that about 90% other countries are also engage in wastewater, but none of the Israeli country that recycle maximum amount of wastewater. Israel, okay, quite famous. Okay, this was question number 6. Uh, usually public acceptance of recycled water is highest for, obviously not for drinking purpose. Bathing also is not done. Fish farming and food crop irrigation. Fish farming is not happening. Watering lawns and all. D will be correct answer. So obviously, while there is a growing acceptance, it's not okay now. Bathing this may be more acceptable than potable usage, but still some concern about direct skin and all these. This may be acceptable, but there are still concerns about safety, especially regarding consumption of food grown on the recycled water. This generally enjoy the highest acceptance as involve minimum health risk and less controversial, making it preferable option for many people. So D, thus the D is option where the people acceptance of it is the highest. Question number 8. Try to answer it. I will be back in 1 minute. Okay, so focus of research on water and energy nexus is on exploring. I think we can see that all of these they are like they are investing in everything. More energy efficient technology for water and wastewater treatment, energy production and recovery from wastewater and sludge processing. Then optimization of energy usage in water supply. Then we have all of above. Okay. Yes. Given that understanding, except interaction between all of the answer. Okay, now. Then globally, some of the most success story of a cycle include. This is very simple question. See, in India, this is not a famous story, so this won't be also our answer. Similarly, Australia, this story of this area is not famous. Story of Queensland is very famous, so that's why this will be also not. Paris story is also not famous. But Orange County and Singapore New Water is very famous. They have managed. We have seen stories. Okay, so the answer will be B. The correct answer is B. Singapore New Water and Orange County in California, United States. Singapore New Water is the example of successful large-scale wastewater recycling program that produces high-quality reclaimed water for various including purpose. On Similarly for why not? While Tubamba did discover recycle, but it faced significantly public opposition and was not successfully implemented on large scale. Paris in France is less recognized as major success story in water. Also, Bangalore has made a stride in wastewater, not widely recognized for successful as compared to global examples. San Diego has implemented subwater sinking, but obviously these are not so much famous. Okay, but for other cases, it's good. Identify the correct statement regarding the public acceptance of the recycle wastewater. Okay, people with high level of education often have higher level of acceptance. Okay, knowledge about recycling technology and safety measures being taken up by utility results in greater. So the answer of this is both correct. Okay, now yes, if you are educated, means like people are started to, and if some proper knowledge is being given, all the guidance, all the thing is given, then we have more tendency to accept it. Okay. So yes, research has shown that the individual with higher level of education tends to have a better understanding of environment issue and water management, which can lead to greater acceptance of recycled water. This may be more informed about the safety and benefits of recycle practices. A statement to so see this was correct. A statement to familiarly with technology safety protocol environment. Obviously we have seen if you even if you are not educated and if you are going to a village and saying that this is how the wastewater is being produced and all these things, then it's obvious that they will understand it and they will use it. And I have seen my on my own that when we were giving some kind of a solution to them, people were accepting it. Which of the following statements below the correct about the public acceptance in the wastewater? Younger population are more accepting the recycled wastewater. Women are more accepting than men. Religious people are more willing to know. Religious people are probably same reason that this is wastewater, not fresh and all this thing. Again, research has found that men are accepting more than women. The correct answer is, but a younger population like us is accepting more. The studies have indicated that a younger population tend to be more open to the ideas of using recycled water, possibly due to greater awareness of environmental issues and sustainability. This was a straight simple question. Women partially incorrect. While some studies suggest that women may have higher level of concern regarding health and safety related to recycled water, the acceptance level can be vary widely and may not may not consistent so that women are more accepting than men. People, religious people are more willing to use recycled water than non-religious people. Correct. Researchers have shown mixed result on the relationship between religious benefits and acceptance of the recycled water. Generally, acceptance may be very cultural. Again, we have discussed this thing. Okay. Thus, age the more accurate answer. Hmm. Question number 12, yuck factor. We have already discussed this yuck factor. Unfair distribution, no traffic discharge, discussed about idea of using wastewater. Okay, this was straightforward. This refers to emotional perception or version of people feel toward the concept of using treated wastewater, leading to public protest against the recycling schemes. Generally, this is seen that they don't want to use this recycled water and all this. Question number 13, portable reuse system for wastewater recycling in Singapore and USA typically advanced treatment technique including. I have shown you this thing. Okay, na both places uses advanced technology and all this thing. What are those advanced technology? If you want to, we can go here around around the world. See, this is success story. This is failure story. Singapore. See how they use it. You can see water reverse osmosis. First microfiltration is there, then reverse osmosis, then UV. Okay. Similarly, in Australia, we will be seeing Australia. In Australia, I think same practice is done. Okay, na. In Australia, also same practice is done. So, what our option? So, see this. See C option microfiltration, reverse osmosis followed by UV. You can see from this picture. Where is the picture? Where is see macrofiltration first. What will happen that water with there will be water reclamation plant. Sorry. Hey, then there will be macrofiltration. Reverse osmosis will be there. Then there will be ultraviolet, and finally we will have new water, treated used water. Okay, na treated wastewater. Remember, treated wastewater. Used water means treated wastewater in there. Okay. So the correct answer is C, microfiltration, reverse osmosis, followed by UV. This process removes the suspended solid and larger pathogens from wastewater, acting as a pre-treatment state. Then reverse osmosis, this advanced treatment method effectively removes the all contaminant this thing. Then finally we have UV disinfection. Okay. After MF, RO, and UV, disinfection is used to eliminate any remaining pathogen and ensuring the water is safe to drinking. This combination of advanced treatment techniques is widely implemented in potable sewage, ensuring the treatment is mandate under. I have shown you one report. Again, for this thing, we can refer to this slide. ZLD zero discharge, zero liquid discharge. ZLD zero liquid discharge. Okay. Hmm. So they have their own policies and all this thing. So the correct answer is B. The correct answer is zero liquid discharge. Generally liquid discharge is this environmental employee ensuring that all the industrial effluent are treated and no liquid waste are recharged into environment. Under general, industry are required to recycle and reuse wastewater completely, thereby minimizing environmental pollution and conserving water resource. The other option, while related to water sanitization, is do not specifically mandate and complete. So the correct answer is B. Okay. Finally, our final question of the day or of entire session. IUWM considers this thing I have not discussed. Okay, now. So see, integrating water means not directly. I think I have discussed it somewhere. Just let's so see the I this IUMW integrating wastewater, storm water, and integrated urban water management. This IUMA stands for integrated urban water management. Focuses on managing various water resources in an urban environmental holistically. This approach emphasizes the importance of considering the wastewater, storm water, and rainwater as valuable resource that can be reused and recycled within the urban water cycle, thereby promoting sustainability and resilience in urban water management. Okay, so the correct answer was A. So that was for today. We have 5-10 more minutes. If anyone have any kind of doubt, you can ask, or we will be ending the session here. So on on Saturday we have one extra class. So of 1 hour, 2 hour, depending upon how many of you join. So I think today also only 3 people have joined. 4 people were there, but 2 left. I will request you to for please do join. No, I will. So I will be taking some session and all these things. So do join it. And if anyone have any more question, they can ask right now, or we can just end the session here. Okay, so